Hi, in today's video, I'll be giving a short introduction into combinatorics. Specifically, I'll be looking at permutations and the basic counting principles. So let's get into it. The first counting principle we should know is the addition principle. We've been using this principle since we're very young, and intuitively, it just means that if you have different events occurring that do not overlap, the total number of ways this event can occur is just the sum of each individual number of ways each event can occur. Let's take for example, you have a lunch menu, you have the option of a chicken dish, a fish dish, or a pork dish, and you can only choose one out of the entire menu. So in the chicken section, you have 3 options. Let's say for fish you have 2 and for pork you have 2. Then the total number of ways, because chicken, fish and pork are all not overlapping, you can just add them up, and this will result in the total number of ways to select your lunch option. Let's look at a more complicated example, but it works on the same principle. So now we want to find the number of ordered pairs such that x squared plus y squared is less than 5. And we can now break our problem into 6 cases where x squared plus y squared is 0, 1, 2, all the way to 5. And obviously, if x squared plus y squared equals to 0, it cannot equals to 1. And so, breaking them down and listing them, we are able to count the number of ways by adding up the total number of options in each event. Moving on, we have the multiplication principle. This principle is also what we use in our daily lives, and to write it formally, it just means that if our event can be broken up into ordered events, then the total number of ways is the product of each number of ways per event together. So let's take an example again. You have a set menu lunch now, and this time your main has 3 options. You can choose one of the 2 drinks, and your dessert, you have 2 options. In this case, because you have 3 options for a main, you can do it this way. You can choose A, B or C first, and from each A, B and C, now it's an ordering, and so it's an arrangement of what you're going to choose. And so the next option, you have 2 for each of the A, B and C, and lastly when you choose the dessert, you have 2 again. And so the total number of ways is now 3 times 2 times 2. Yep, that's all for the multiplication principle, and you can see how fairly intuitive it is when you apply it to your daily lives. So a more concrete example of using it will be, for example, we want to sort and arrange 26 letters in the alphabet, and there's no restriction on how we're going to sort it. So the original alphabet, there are 26 letters, so it's A to Z. But now we have these 26 elements and we want to rearrange them. And so the number of ways of these rearrangements is 26 factorial. And the reason for that is now in our first slot, we can have 26 choices. Our second, we have 25, and all the way to the last slot, we have 21. We have 1. And so the total number of ways is 26 times 25 all the way to times 1. And that is defined to be 26 factorial. Next, we'll move on to the third principle, the complementation principle. This principle is actually just the application of the addition principle. So it just says when you have 2 events that are complements of each other, which already is defined to be non-overlapping or disjoint, then the total number of ways minus its complement is the number of ways the event that you want has occurred. For example, you know that there are 30 animals, 25 of them is dogs and 5 of them is cats. you see the surrounding and you see that there's fewer cats, so it's easier to count the cats. And you count that there is only 5 cats. The question now will be, how many dogs? It will just be 30 minus 5. And you don't need to count the number of dogs. And that is an application of already the complementation principle. And so you can see that these 3 principles are heavily used in our daily lives and they are very intuitive. Now, let's touch on one of the counting techniques, which is to count the number of arrangements based on a given set of n elements. These arrangements are defined to be called the permutations, and so the ordering of it matters since we are arranging them. Take for example our 26 objects in a row. That's basically what we have already done of the 26 alphabets. And so the answer is 26 factorial. But now we want to generalize this to not just only having the total number of objects, and say we want 3 out of the 7 objects arranged in a row. Then we can have 7 choices in our first slot, 6 choices in our second slot, and 5 choices in our third slot. And so the remaining 4 that are not chosen, well, there's nothing we can do about it, and so it is just 7 times 6 times 5 is the total number of ways. And you can see that actually is the formula of 7 factorial over the 4 factorial that is not chosen. And so this is basically all about permutations. And what I like to do is always to draw out the number of boxes that I need or the slots that I want to put my objects in and just arrange them through the multiplication principle. So you don't really need to memorize the formula, but understand that it is just based on the multiplication principle. Moving on, we can work on something a bit more complicated, which is the arrangements around a circle. So in our first case here, we arrange them in a row, or also known as the linear order. For the arrangements around a circle, let's say we have n objects over here. So we got 1, 2, 3, 4, 5, 6, 7, where in this case our n is 7. Then we want to arrange them in a circle. We could arrange them in this way, or we can shift this 1 over here. So it's 1, 2, 3, 4, 5, 6, 7 now. But you can see that this rotation makes the arrangement exactly the same as the previous one. And so for each arrangement, it is actually repeated 7 times by the rotations. And so each arrangement actually corresponds to 7 arrangements. And so if you arrange them in a row first, you need to divide each of the arrangements by the number of objects, because the number of objects denotes your rotation. And so the formula is just PNR over R. This is how you arrange the objects in a circle, and we'll move on to a problem to better understand what I mean. So for example, now we have 5 boys and 3 girls, and they're to be seated around a table with no restrictions. Well, based on the formula, this just means that it is Q 8, 8, which just equals to P 8, 8 over 8. And this is just 8 factorial over 8, which just makes it 7 factorial. Next, we want to arrange that the boy 1 and girl 1 are not adjacent. And to do so, we can first draw a picture to visualize it. So boy 1 and girl 1 are not adjacent. So you can arrange the other 4 boys first. So let's say the other 4 boys are arranged in this way, and then you arrange, and then with the other 2 girls, of course. So now the girls are arranged this within them, and the number of arrangements here will be just 6 factorial over 6. So that gives us 5 factorial. Then, since they are not adjacent, we just need to slot them into the corresponding slots, and we will be assured that since we are slotting them, there will be a person in between them at most. So now with 6 slots, but now these slots are all distinct. We have 6, and we can choose. This slot can have, this boy can go into any of the 6 slots, and the girl will just have to go into any of the other 5 slots. And so it's 6 times 5, which is 30. And by the multiplication, the total is just 5 factorial times 30. So moving on to the last problem, where no girls are adjacent. Well, that's just arranging the boys first, which is 4 factorial, and then just slotting the girls afterwards, and there's 5 slots. And so the first girl has 5 choices, the second girl has 4 choices, and the third girl has 3. And so we can see how we have used what we have learned previously on the multiplication principle, and now arranging them by multiplying them together. Lastly, I'll just cover a simple proof of this combinatorics identity. So it is saying that if you have n plus 1 elements in total, and you want to arrange only r of them, the way to do so is actually you can split them into 2 cases. Well, the first case is that n plus 1 is not in the arrangement. That means that you're taking a subset of 1 to n and arranging r of them, and so it's actually just p and r. But in the case 2, it has to be the complement of it to use the addition principle, and so n plus 1 is in the arrangement. But now you only have r minus 1 other elements to arrange within the 1 to n set first. And so you arrange them first, so that gives you the p and r minus 1, and with that you have r slots, and so your n plus 1 element can choose any of these r slots to go in to add on to the arrangement, and so the total number of ways there will be r times p and r minus 1, and hence this total number will just be equals to the 2 cases add together. Yep, that's all for understanding the basics of permutations, and I have hoped you have learned something from this video. If you like more of this content, please feel free to like, share and subscribe, and you can comment on anything you do not understand. I'll be sharing the slides, and then you can just read and understand it more on your own free time. Thank you.